Okay, we have two more example hypotheses tests to run through, but these are going to go by a lot faster because we're going to skip that really super fun checking conditions. We definitely have all the information and all of these problems to do that, but we want to just move through them a little bit quicker, so we're going to skip that part. So in this one, we have a group of medical researchers knew from previous studies that in the past, about 39% of all men between the ages of 45 and 59 were regularly active. Because regular activity is good for our health, the researchers were concerned that this percentage had declined over time. For this reason, they selected a random sample without replacement of 1,927 men in this age group and interviewed them. Out of this sample, 680 said that they were regularly active. Okay, we want to carry out the hypothesis test to determine whether the proportion, what's important here, proportion and percentage. So again, these are all those P's, they're percentages. We know we're going to run this test, this proportion stats, and we're going to get a Z value for it. We're testing whether the proportion of regularly active men in this age group has declined. And we are told here to use that significance level of 5%. Okay, so the first thing we need to do is write our null and our alternative. The null would be the boring idea that nothing at all has happened, that the percentage is still 39%. We're trying to provide enough evidence that specifically this has declined so that it is now less than that. Just to see what happened in our sample. In the sample, 680 of the 1,927 said they were regularly active, and if you divide that out, it is, let's see, right around 35%. So in the sample, it was a little bit lower, but not a lot lower. So basically what the hypothesis test is going to allow us to do is to decide, well, was that a big enough difference there that we can claim, yes, this percentage is going down? Or was that the fact that that percentage came back a little bit lower just due to the random sampling process? Was it, if we did it again, would we expect to get something closer to the 29 or the 39%? That's what the hypothesis test does for us. Okay, so we're going to skip checking our conditions, but we do need to write down at least that alpha value that we're going to use is 0.05 and that we are calculating a Z statistic on here because, again, these are proportions. It tells us which test to run. Okay, now we're going to rely on StatCrunch to do the actual computation for us, but we need to tell it the number of successes and the number of observations. So the observations were the 1,927 men that were asked, and the successes were the 680 who said yes. We're going to go to StatCrunch and run this and record what is the Z and what is the P. Okay, so I'll flip over, go to my stat proportion stats, since I've determined that I'm talking about percentages. One sample with a summary again. Put in the 680, 1927, running a hypothesis test. We were checking, we thought it was equal to 39%, and we're specifically trying to show that it is now less than that. And I'm going to go ahead and make that p-value plot again. Compute, note your Z and your P, and record those on your paper. I'm going to go ahead and flip back over so that I can record those. So the Z was approximately negative 3.34 and the P was 0.0004. And then the last thing to do is to take that p-value and use that to interpret. So I start these off the same way. Since P, and I compare it to alpha, alpha again being 0.05, so in this case it is less than alpha. So since P is less than alpha, we reject, again, smaller value, smaller sentence. We're rejecting the idea that it was still 39%. So if we reject, so we're rejecting this, which means we're going with this. So I need to make a statement now for that one. So I conclude that the percentage of regularly active men aged 45 to 59 has decreased from 39%. I can make that statement. I can, in this case, say it decreased because that's what I was testing. What does this look like? What kind of hypothesis do we have? Well, this one is one-sided. It's a less than. So what should happen on this one is we should go out to that z value, that negative 3.34, so it should be way out here. And it's only one-sided, so we're only doing this left-hand side. We don't have the other side for it then. And what we can do is we can check that matches with what I just said. They're back at 3.34, and they put their marker there, and they've shaded to the left of that. So very, very small probability of this happening again. Again, the small probability of this happening again means we should go with the alternative because it looks like there's something interesting going on. Okay, let's do one more example, and we'll call section 8.2 good. We've talked about Samuel Morse before, and this time we're interested in the T's in the English language. In the 1800s was 9% is what he says. Then we took a sample of 600 random letters, it was a random sample, from a current newspaper, and it contained 48 T's. We're going to use that standard significance level of 0.05 and test the hypothesis that the proportion, so kind of a key word there again, proportion in the percents, of T's in the modern day has changed from 9%. So has it changed? All right, let's see. Null, alternative. Our null would be the boring statement of nothing has changed, so that the percent is still 9. More interestingly would be what we're trying to see has happened. Has it changed? Again, change is either direction. So change would just be, it's not this anymore. Okay, we're going to skip the conditions, but we will still record that we are using an alpha of 0.05 again, and we are using the z-test statistic because, again, we've got the proportion idea here. Okay, compute. So we're going to go to StatCrunch and tell it how many successes and how many observations. So observations, there were 600 letters observed. 48 of them were T's. So let's go see if there's enough information here to say that there's a change or not. Close. Let's go back out and start again. We're going to go again with one sample and a summary. There were 48 T's out of 600 letters. Hypothesis was that it was 0.09 or that it was not 0.09, so everything is good there. I'm going to make my plot, and I'm going to compute. Check out that Z and that P value and record those on your paper with me. So the Z value came back as negative 0.856, and the P came back as 0.392. Okay, for our interpret, since P, so this is different. We haven't seen this one before. This time P came back bigger than alpha. right? It's 0.392. That's much bigger than 0.05. When it comes out larger, we have to use the longer sentence. So we say here, we fail to reject the null. I have failed to show enough evidence to overturn this. So I cannot go with this one. I have to stick with this. So a lot of times what they say is like, there is not enough evidence to conclude the percent of T's has changed from 9%. That's one way you could say it. Or you could simply just say the percent of T's is still 9% according to this. But a lot of times they say it in that kind of phrasing, we did not find enough evidence to conclude, to like go with the alternative. So we have to just stick with that default, boring, standard, status quo position that it's still 9%. What does this one look like? So this was a two-tailed again, because it was a not equal to. The P came back at 0.392. So, oh, sorry, not the P, the Z. The Z is where we need to mark. So negative 0.85. So here. And because it was two-tailed, we also mark that over here. Oops, that's a very, very bad line. And the p-value is all the shading then that is beyond that. So quite a lot actually being shaded here. Very different from the other ones where our z's were so far out that we had hardly any shading at all. That's why the p-value on this one comes back so large. Again, I can look at it here. Very similar to the one I just drew. So what we could kind of say here is that there is a very large chance, a 39.2% chance or probability that the null is true and we see another outcome this extreme or more extreme. So we could say this could certainly be due to chance. There's not enough evidence to say anything has changed. If we were to do this more and more times, we would probably, there's a really good